Hello friends, you all are welcome to my physics class. Today we'll be looking at nature of images formed by curved mirrors. Now there are two types of curved mirrors. We have concave mirror and convex mirror. Convex mirror. And to begin with, we are going to be looking at the nature of images formed by concave mirrors using ray diagram. This diagram is called, the diagram here is called ray diagram. So let's start with the concave mirror. Is a diagram of a concave mirror. Good. Now, for an object placed beyond the center of curvature, C is the center of curvature, F is the principal focus, and P is the pole of the mirror. We all we can remember that when um, object is placed beyond C, we have here rays parallel and close to the principal axis. And we know rays parallel and close to the principal axis will converge as the principal focus after reflection. Rays parallel and close to the principal axis will converge as the principal focus after reflection, while rays through the center of curvature will go undeviated. Now, the point where these two rays meet forms the head of the image. So this is the image. So from here, we can easily deduce that the image formed when the object is beyond C, the image formed by a concave mirror when the object is behind C or beyond C is real, inverted, and diminished. Real in the sense that it can allow light to pass through it, and so it can be captured on, on a screen. So good. Now let's also look at the next the, the, the next stage when the object is at the center of curvature. Let's look at the nature of the image formed when the object is the mirror, when the object is at the center of curvature. By the way, center of curvature is the center of the sphere from which the mirror was cut. Okay, so now the object has moved to this point. Remember, rays parallel and close to the principal axis will converge as principal focus after reflection, while rays through this center of curvature will go undeviated. Now this is where the image is formed. Remember where the two rays meet or intersect forms the head of the image formed. From here, we can see that the image formed is real as well, inverted, and same size as the object. Same size as the object. Good. Now let's move the object now to this point. Let me clean this. The object is moving closer and closer to the mirror. And the object is the mirror. The pole is the principal focus, center of curvature. Now the object is somewhere here. Once again, rays parallel and close to the principal axis will converge at the principal focus after reflection. Good. Y rays through the center of curvature. Y rays through the center of curvature. We move undeviated. So good. So this is where the image is formed. The image is formed behind center of curvature. The image is formed behind the center of curvature. The image is real, inverted, and magnified or enlarged. And magnified or enlarged. So this is the nature of the image formed when the object is between. This is the object, is the image. When the object is between C and F, we already know what C and F stand for. Now let's look at the next stage, where now the object has moved to F. The object is right here, F. Once again, rays parallel and close to the principal axis, they converge as at the principal focus after reflection, while rays through the center of curvature will go undeviated. So these two lines are parallel. The ones are parallel. So the nature of image formed, now they will meet at infinity. If ever they will meet, they will meet at infinity. So the image is formed at infinity. Image is formed at infinity. The image formed at infinity. Formed at infinity. The image will also be what? Inverted, if formed at all, and it will be what? Enlarged. The image will be enlarged. Good. Now, now the object is moving closer. You can guess where the object will be in the next stage. So guess, if your guess is as good as mine, then will be the object will be between F and the pole. The object is right here. Wait. We are using dot dots here because this is not real, virtual. That is, it cannot be, light is not truly passing through this point. It is virtual, so it cannot be captured on a screen. We are using dotted lines here. The image, the two lines we meet here, somewhere here. Remember, where the two lines meet form the head of the image. Is the image formed. So say the image is virtual, image, image is virtual, image erect, and enlarged. The image is virtual, erect, and enlarged. Virtual in the sense that it cannot be captured on the screen because light is not passing through it. Okay. Good. That is all there is for images formed by a concave mirror. Now let's look at the images formed by a convex mirror. By the way, concave mirror is also called a converging mirror. Uh, let's quickly look at the nature of images formed by a convex mirror. A convex mirror. Convex mirror. Example of a convex mirror. So for a convex mirror, whatever the position of the object, the image formed has the same nature: diminished, erect, virtual. So good. This is the focus, principal focus here. And C, remember, if you remember, C is equals to 2F. That is C. Sorry, the distance, that is distance from here to here. This is also called radius of curvature, R. So R equals to 2F. Good. So that's just by the way. So continue. So assuming the object is here, we hit the surface. After reflection, to converge here. It's not supposed to be a continuous line because it's a virtual image. A virtual image. A virtual image. So why we want through here, we go undiverted. So the two images meet here, the two lines meet here. So this is the image form diminished, erect, virtual. So whatever the position of the object, whether it is here or here, the image form will be diminished, erect, and virtual. So good. These are the properties of images. These are, or rather, the nature of images formed by curved mirrors. If, like I said before, curved mirrors are divided into two. There are two types of curved mirrors. We have concave mirror and we have convex mirror. For concave mirror, we mentioned the nature of images formed. The nature of images formed vary, according to the position of the object from the mirror. While for a convex mirror, the nature of the image formed is the same, regardless the position of the object. See you next time. This is where we draw the curtain. See you next time. Thank you for watching.